In this video, we'll show you how to use ITK-SNAP's semi-automatic segmentation tool to create accurate and consistent segmentations. We will start by opening the image in ITK-SNAP. To do this, simply drag and drop the file directly onto the platform. Once the image is loaded, we will adjust the contrast to obtain a clear visualization of the structures. In general, a contrast range between 500 and 800 works well. If necessary, slightly adjust the values until there is a good distinction between densities. When the rendering looks correct, we can move on to identifying the relevant slices for segmentation. The goal is to define the range of slices we will work on. In this example, segmentation will start around slice 445 and end around slice 560. We will now create a new segmentation. To do this, click on Segmentations, then select New Segmentation. Name it, for example, Manual Segmentation. Before starting, double-check the contrast and the selected area. If the display is satisfactory and the boundaries are correctly defined, we can move on to the next step, the actual segmentation.
We will now begin the segmentation of the vessel, that is, the lumen, the thrombus, and the calcifications. For segmentation convenience, we segment the vessel in red, and we will later assign it to the green label. For now, everything will be grouped under label 1, so that we work on a single segmentation layer. We will start from slice 445, which corresponds to the lower boundary of the region of interest. This first slice will be segmented entirely manually, since the snake algorithm does not regularize the upper and lower slices, meaning the superior and inferior limits of the volume. For this step, we use a large brush size. It's important to be especially precise along the edges, as this part will not be automatically corrected later on. We carefully complete the contours, and repeat the same operation on the upper slice of the region of interest. The undo and redo functions will be used frequently throughout the segmentation process. This is a simple but essential step to verify how each modification affects the result and to ensure that the contours remain aligned with the anatomical structures. The first slices are now segmented. In 3D view, we can clearly see the portions of the vessel that have been processed. Next, we will launch a semi-automatic segmentation using the snake tool. To do this, we will define the intermediate zones on which the snake will propagate. That is, small volumes between the two already segmented ends, which will serve as anchor points for the propagation. We activate the 3D brush to paint simultaneously in the axial, coronal, and sagittal views. We place several bubbles along the vessel, paying special attention to the narrower areas. When needed, we deactivate the 3D mode to gain precision. And remember to save the project regularly, as shown here before running the snake. Now, we will define the 3D region of interest, ROI, for segmentation. It must cover the entire target area, from the first to the last relevant slice. Make sure that all important arteries are included within this region. Once this is done, we initialize the snake parameters from the current segmentation, and save the project again for safety. Next comes the definition of the intensity thresholds. We will use the intensity map to better visualize the propagation. In general, we choose a fairly wide range of values to include the calcifications. Here, we will set the lower threshold around 200 and leave the upper threshold at its maximum to capture all vessel structures. During the first propagation, the segmentation spread a bit too far, particularly into unwanted areas, such as the pulmonary artery. So we ran a second propagation, with fewer iterations, to better control the diffusion. The result is already more precise, although some regions still appear slightly too wide. We will now proceed with the manual corrections to refine the contours. Feel free to use the other views to complete the segmentation. If you find any labels that were applied by mistake, remove them using the eraser tool or by right-clicking with your mouse. We now move on to the aneurysm, which we will need to segment manually. In this area, it's important to be as precise as possible with the brush, since it will be much less regularized. For this part, it's recommended to use a smaller brush size, zoom in if necessary, and work slice by slice. Once the main segmentation is complete, the next phase consists of regularizing the contours. The regularization begins on the ascending portion of the aorta. Since this area is relatively homogeneous, it is recommended to increase the smoothing force parameter in order to obtain a smoother and more consistent result. The same process is then applied to the other sections: the aortic arch, the supraaortic branches, and the descending thoracic aorta. For each area, the method remains the same. Precisely define the working region. Adjust the intensity thresholds to control propagation. Modify the smoothing parameters and the number of iterations. Check the rendering before validation. It is recommended to test different parameter combinations in order to find the best balance between accuracy and smoothness, depending on the anatomical characteristics. Finally, the phase concludes with local manual corrections, particularly around the origins of the supraaortic arteries, where details require special attention. Step 3. We will now assign a color to the thrombus and proceed with the lumen segmentation. Let's begin by selecting the Scalpel tool. When this tool is selected, a red rectangle appears in the 3D view. It represents the cutting plane. A green arrow indicates the direction of the cut. Use the flip option if needed to reverse the arrow's direction, and therefore the affected area. In this example, the entire segmentation must be transferred under the green label, which corresponds to the thrombus. Once the labels are correctly assigned, click Accept to confirm the change. We will now move on to the lumen segmentation. Since the lumen is part of the same vessel, it will be segmented in red, directly inside the green area, and the same principle will apply when using the snake tool. Let's take the supraortic region as an example. For each section of the vessel, the methodology remains the same. First, manually define the limits of the region to be segmented. Define the region of interest for the snake by outlining the 3D box around the targeted area. Make sure that the top and bottom edges of the 3D box exactly match the slices you manually defined at the beginning. Initialize the lumen by placing several small seeds under label 1, in areas where the presence of the lumen is certain. These reference points will help guide the snake propagation. Restrict the propagation. Make sure that label 1, the red lumen, propagates only within label 2, which represents the green thrombus. This ensures that the snake does not extend into adjacent regions, with similar intensity values that were not segmented under label 2. Next, adjust the intensity thresholds using the intensity map. As a visual guide, you can use a calcification as a reference point. And ensure that the propagation does not invade this area. For smoothing, the recommended approach is as follows: start with a low smoothing value, to allow the segmentation to propagate effectively, then gradually run the iterations. Once the propagation looks satisfactory, increase the smoothing force parameter to regularize the contours and achieve a smoother final segmentation. Finally, review the segmentation in axial, coronal, and sagittal views, make manual corrections if needed, and remember to save your progress regularly. We will now quickly go through the segmentation of the remaining areas of the vessel. We apply the same segmentation workflow to the remaining areas of the vessel, defining the region of interest, adjusting thresholds, and refining with the snake tool. You should now have a clean and consistent lumen segmentation, accurately aligned with the thrombus. In this final step, we will proceed with the final adjustments. The goal is to correct small imperfections left by the snake algorithm or minor artifacts noticed after propagation. For example, in this area, the snake slightly overextended into the thrombus. To correct this error, we simply use the brush tool to redraw the thrombus area over the lumen. In other words, to apply label 2 over label 1. These corrections should remain minimal, so as not to alter the smoothness of the vessel. Since this is a sensitive region, it is recommended to check the other views and adjust the brush size according to the required level of precision. Pay particular attention to calcifications, to the boundary between the lumen and thrombus, to any holes or discontinuities, and to areas misinterpreted by the snake. Then, review each slice to ensure overall consistency. We will now remove unnecessary thrombus, that is, small isolated regions that do not correspond to real thrombus but rather to the vascular wall. A quick cleanup is sufficient. Delete only the zones where it is clearly evident that no thrombus should be present, while avoiding the removal of regions close to calcifications, as these must be preserved. It is important to emphasize that a segmentation performed by a single person is difficult to validate on its own. This segmentation represents a first working version, and these corrections will be reviewed during the validation phase. This review step ensures the consistency, accuracy, and final quality of the segmentations.